Hey everyone, so this is the next section that we are going to talk about. Chapter 7 is in Chapter 7, Section 7.4 is special products of polynomials. So products we know is another word for multiplying. So special things that happen. We're going to notice there's some patterns here. When we multiply polynomials, there are special rules that we're going to see come up. So this first little box here is just an introductory activity. We know how to do A and B. Okay, so take a moment, pause this video, do A and B, multiply those together just like we learned in 7.3. So now after you've done A and B, I'm just going to do a little refresher here, and you can check your work. So remember, when I multiply two binomials together, we can FOIL, which is really just distributing. So we distribute the first numbers together, x times x is x squared. Then we distribute outer, x times -3 is -3x. Then we distribute inner, 3 times x. And then we distribute the last. 3 times -3 is -9. Let's see here. When we do this, notice we're going to combine like terms. -3x plus 3x, well, that's 0. So I'm really just left with x squared minus 9. Notice there's a little bit of a pattern from what we started with to what we got. And let's see if we can notice the same pattern. First, I want you to notice that these binomials are identical, right? X and 3. One's just x plus 3 and one's x minus 3. Same thing with B here. One's 2x minus 5, the other one's 2x plus 5. So this is special. They're almost identical binomials. I'm going to distribute here. Almost identical binomials, so that means something special is going to happen here. Again, notice 10x minus 10x, well, that's going to be 0. All I'm left with is 4x squared minus 25. And there's a connection here between my original and my final answer. And it's very noticeable in A. Notice it just is that 3 getting squared to give me 9. Okay, and the x getting squared to give me x squared. Same thing here. The two x's are the same. 2x times 2x gives me 4x squared. And then the 5's are the same. 5 squared gives me 25. So there's some patterns that come up there. C and D, what we have to remember is this note right up here. That's so important. That when we see AB squared, it is not a squared plus b squared. That is not true. We cannot distribute that exponent to everything. That's what this is. That is not true. What we need to know, and you guys can write this down in here, is a plus b squared is really a plus b times a plus b. There's two of them, right? Just like you would do 5 squared is 5 times 5. A plus b squared is a plus b times a plus b. We have to remember that. And again, that's something you're going to see for the rest of your math classes. So when I see C here, I'm going to just rewrite that as z plus 1 times z plus 1, and it turns into a problem like A and B. Z times z is z squared, z times 1 is z, 1 times z is z, 1 times 1 is 1. And I end up with combined like terms here, z squared plus 2z plus 1. Same thing for D, z minus 1 squared. I'm going to rewrite that right away. And then I'm going to FOIL or distribute. Z times z is z squared. Z times -1 is negative z. -1 times z is negative z. -1 times -1 is a positive 1. Combine like terms here. And look at these two answers. They are very similar. All that's changing is I've got a plus and a minus. So what are these rules, guys? The rules, these are called the sum and difference pattern, or the square of a binomial pattern. This is called difference of squares, and it's really important, this first one. When we see a plus b times a minus b, all that really is a squared minus b squared. Okay, and that's what happened above in the discovery activity. So x plus 3 times x minus 3 is really just x squared minus 9. All we have to do is find the a term and find the b term and square them. Okay? For square of a binomial or sum of a square is that we are doing a squared plus 2ab plus b squared. If we can identify what a and b is, all we do is just substitute right into this formula. Same thing down here, a squared minus 2ab plus b squared. So if I can say, okay, here's my a, here's my b, I don't have to FOIL, I don't have to distribute, I just use these formulas. If x is a, everywhere I see an a in that formula, I'm going to substitute in an x. So I've got x squared plus, notice the b term is 3, so I'm going to have substitute 2 times the a, which is x, b is 3, plus b squared. And I end up with x squared plus 6x plus 9 is my answer there. All from just substituting right into the formula. Again, if this is my a, negative 3 is my b, substitute it right into the formula. I've got x squared minus 2 times a, which is x, times 3, times b, which is negative 3, plus negative 3 squared, and I end up with x squared plus 6x, well, I'm sorry, minus 6x. Because this should be a positive 3. Let's fix it. Positive 3, this is b is a positive 3, minus 6x plus 3. Okay, we can use those same patterns above to solve these problems here. So if I look at a, I'm going to just say my a is x and my b is 4. And which pattern does a look like? Sum and difference pattern or square of a binomial? Hopefully it looks like sum and difference pattern. And I'm just going to use this formula. I'm going to do a squared minus b squared. And I get x squared minus 16. So guys, you don't have to do this. If you don't want to do this, you just go back to FOILing and distributing. If I look at b, and I notice it's either a square of a binomial or sum and difference pattern because I have the same binomial, just different signs, right? All of these have the same, just different signs in between, or the same. Okay, so here I notice again, this is sum and difference. 2g is a, 5 is b, and I'm going to go right into this formula, a squared, so that's 2g squared, minus b squared, so that's 5 is my b squared. 2g squared is 4g squared minus 25. Okay, and let's check out c. Is y plus 1. This is a square of a binomial pattern. A is y, b is 1. And I'm going to go right into this formula. A squared is going to be y squared plus 2 times my a times my b plus b squared. All I'm doing is substituting in. And I end up with y squared plus 2y plus 1. If that isn't making sense, all you have to do, guys, is expand that and FOIL or distribute. This is just a shortcut. Here's your A, here's your B. Which pattern does it match up with? This one. So I'm going to substitute right in 2z squared minus 2 times A times B plus B squared. And I end up with 4z squared. 2 times 2 is 4 times 3 is 12, negative 12z plus 9. Okay, this is just a shortcut method. We will practice this more. Great job, guys.